lifespan of cable ties depends on various factors, primarily material, environment, and usage. Considering material, nylon cable ties typically last 5 to 10 years, depending on exposure to sunlight and moisture. Stainless steel cable ties are extremely durable and can last indefinitely. Polypropylene cable ties are less durable than nylon, lasting 2 to 5 years. The environment also plays a significant role. Sunlight, specifically ultraviolet rays, damages nylon cable ties, causing them to become brittle. Moisture can corrode metal cable ties and degrade plastic ones. Extreme temperatures, both heat and cold, can make cable ties more susceptible to breaking. Contact with chemicals like solvents or acids can weaken cable ties. Usage is another critical factor. Over-tightening cable ties can damage them and reduce their lifespan. Using cable ties for purposes they are not designed for can increase stress and shorten their life. Typical lifespans vary based on the type of cable tie. White nylon cable ties last 5 to 10 years with moderate exposure to sunlight and moisture. Ultraviolet-resistant black nylon cable ties can last 10 to 15 years. Stainless steel cable ties can last indefinitely. Polypropylene cable ties typically last 2 to 5 years. Signs of degradation include brittleness, where cable ties become stiff and easy to break. Discoloration, where nylon cable ties may turn yellow or brown due to ultraviolet exposure, is another sign. Rust can weaken metal cable ties. Cracking, where cable ties develop cracks or splits, is also an indicator of degradation. It is recommended to use ultraviolet-resistant cable ties for outdoor applications. Protect cable ties from moisture and extreme temperatures. Avoid over-tightening them. Inspect cable ties regularly and replace any that show signs of degradation. Consider using stainless steel cable ties for applications where durability is paramount. To elaborate further on the material aspect, nylon is a popular choice due to its balance of strength, flexibility, and cost-effectiveness. However, different types of nylon exist, with some being more resistant to ultraviolet radiation than others. For instance, nylon 6.6 is commonly used, but nylon 12 offers superior ultraviolet resistance and chemical resistance. Stainless steel cable ties are the go-to option when extreme durability and resistance to harsh environments are needed. They are often used in marine, industrial, and underground applications where exposure to corrosion, chemicals, and high temperatures is common. There are different grades of stainless steel such as 304 and 316, with 316 offering better corrosion resistance, especially in saline environments. Polypropylene cable ties are generally used in applications where chemical resistance is more important than tensile strength or ultraviolet resistance. They are often found in environments where exposure to acids, bases, and solvents is likely. Regarding environmental factors, ultraviolet radiation from sunlight is a significant threat to nylon cable ties. Ultraviolet radiation breaks down the polymer chains in nylon, leading to a loss of flexibility and increased brittleness. This is why ultraviolet-resistant cable ties are often black, as the color helps to absorb and dissipate ultraviolet radiation. Moisture can also accelerate the degradation of cable ties. In nylon cable ties, moisture can lead to hydrolysis, a process where water molecules break down the polymer chains. In metal cable ties, moisture can cause corrosion, especially if the metal is not properly protected. Extreme temperatures can also affect the performance of cable ties. High temperatures can cause nylon cable ties to soften and lose their tensile strength, while low temperatures can make them more brittle and prone to cracking. Chemical exposure can also lead to degradation. Solvents, acids, and bases can all react with the polymer chains in nylon and polypropylene cable ties, leading to a loss of strength and flexibility. In terms of usage, over-tightening is a common mistake that can significantly reduce the lifespan of cable ties. When a cable tie is over-tightened, it puts excessive stress on the locking mechanism and the body of the tie, making it more likely to fail. Inappropriate use, such as using cable ties to support heavy loads or in applications where they are subject to repeated stress, can also shorten their lifespan. For example, using a small nylon cable tie to support a heavy bundle of cables is likely to result in premature failure. Regular inspection is crucial for identifying cable ties that are showing signs of degradation. Look for signs of brittleness, discoloration, rust, and cracking. If any of these signs are present, the cable tie should be replaced immediately. For applications where durability is paramount, such as in critical infrastructure or in harsh environments, stainless steel cable ties are the best option. While they are more expensive than nylon or polypropylene cable ties, their superior durability and resistance to degradation make them a worthwhile investment. Additionally, the color of nylon cable ties can provide some indication of their intended use and level of ultraviolet resistance. White nylon cable ties are typically used for indoor applications where exposure to sunlight is limited. Black nylon cable ties are often ultraviolet resistant and are suitable for outdoor applications. Other colors may be used for specific purposes, such as identifying different types of cables or wires. When selecting cable ties, it is important to consider the specific requirements of the application. This includes the expected load, the environmental conditions, and the desired lifespan. Choosing the right cable tie for the job can help to ensure long-term reliability and prevent costly failures. Furthermore, proper installation techniques can also extend the lifespan of cable ties. This includes avoiding over-tightening, using the correct tool for tightening, and ensuring that the cable tie is properly seated and locked. In addition to the factors mentioned earlier, the manufacturing quality of cable ties can also affect their lifespan. Cable ties that are made from high-quality materials and manufactured to strict tolerances are more likely to last longer and perform better than cable ties that are made from lower-quality materials or manufactured to less stringent standards. It is therefore important to purchase cable ties from reputable manufacturers who have a proven track record of producing high-quality products. The storage conditions of cable ties can also affect their lifespan. Cable ties should be stored in a cool, dry place away from direct sunlight and extreme temperatures. Exposure to these conditions can cause the cable ties to degrade over time, even before they are installed. Finally, the application of a protective coating to cable ties can help to extend their lifespan. For example, applying a coating of ultraviolet-resistant paint or sealant to nylon cable ties can help to protect them from the harmful effects of sunlight. In summary, the lifespan of cable ties is influenced by a complex interplay of factors including material, environment, usage, manufacturing quality, storage conditions, and protective coatings. By carefully considering these factors and taking appropriate precautions, it is possible to maximize the lifespan of cable ties and ensure their long-term reliability. For example, in coastal environments where salt spray is prevalent, using stainless steel cable ties with a 316 grade is crucial to prevent corrosion. Similarly, in high-temperature environments, using cable ties made from heat-resistant materials such as Teflon or high-temperature nylon can prevent them from softening or melting. When securing cables in areas subject to vibration, using cable ties with rounded edges can prevent them from cutting into the cable insulation. Furthermore, when bundling cables that are sensitive to compression, using cable ties with adjustable tension can prevent them from being damaged. The use of cable tie guns can also help to ensure that cable ties are tightened to the correct tension, preventing both over-tightening and under-tightening. These tools typically have adjustable tension settings and automatic cut-off features that ensure consistent and reliable results. Regular inspection of cable ties should be part of a comprehensive maintenance program. This includes visually inspecting the cable ties for signs of degradation and testing their tensile strength using a pull tester. Cable ties that fail the tensile strength test should be replaced immediately. In addition to visual inspection and tensile strength testing, infrared thermography can also be used to detect overheated cable ties. This technique involves using an infrared camera to scan the cable ties and identify any areas that are significantly hotter than their surroundings. Overheated cable ties may indicate a problem with the electrical system, such as a loose connection or an overloaded circuit. Proper documentation of cable tie installations is also important for ensuring long-term reliability. This includes recording the type of cable tie used, the date of installation, and the location of the installation. This information can be used to track the performance of the cable ties over time and identify any patterns of failure. Furthermore, it is important to train personnel on the proper installation and maintenance of cable ties. This includes teaching them how to select the correct cable tie for the job, how to install them properly, and how to identify signs of degradation. Properly trained personnel are more likely to install and maintain cable ties correctly, which can help to extend their lifespan and prevent costly failures. In addition to the above considerations, the use of cable tie accessories can also enhance the performance and lifespan of cable tie installations. For example, cable tie mounts can be used to secure cable ties to surfaces, preventing them from moving or rubbing against other objects. Cable tie cutters can be used to trim excess cable tie material, preventing it from becoming a hazard. Cable tie identification tags can be used to label cable ties, making it easier to identify and trace cables. The selection of cable tie accessories should be based on the specific requirements of the application. Finally, it is important to stay up to date on the latest advancements in cable tie technology. New materials, designs, and installation techniques are constantly being developed, and staying informed about these advancements can help to improve the performance and lifespan of cable tie installations. For instance, self-locking cable ties with enhanced locking mechanisms offer improved security and resistance to vibration. Cable ties with integrated strain relief features can protect cables from damage caused by bending or twisting. Biodegradable cable ties offer a more environmentally friendly alternative to traditional cable ties. By staying informed and adopting new technologies, it is possible to continually improve the performance and lifespan of cable tie installations. The lifespan of cable ties in New England, for example, is particularly influenced by seasonal temperature variations and exposure to moisture, including snow and ice. Therefore, selecting cable ties rated for extreme cold and employing UV-resistant varieties is crucial in this region.